Okay, so let's continue with the, so this is still, so we're still in the section 1.3, right? More about functions and their functions.
¿Qué pasó, papi?
And their graphs. All right, so yeah, so we didn't actually finish our discussion about the local minimum, local maximum. And as I said, relative maximum and relative minimum is the same thing. So now let's have an example, and then so I can answer questions like in the homework. So let's say you have the following graph. So let's say, so I have here, let's say -2, -1, 0, 1, 2, and let's say here's phi. And then let's say we have something which looks like right here. Okay. And then this one here goes all the way down, right? So let me just be clear about the points here. So this is like, it goes here. All right, so this is 0 here. Okay, so we have 2 arrows here. So there's an arrow here and there's an arrow here, right? And of course, this is like a negative infinity and this is positive infinity. Anyway, so let's say the question is to find, like in the homework, let's find the values of x. Find the values of x at which f of x has a relative or a local max and local or relative min. Okay. So in this case, so let's start from the left. So we are here on the left. Well, this arrow here, again, guys, it means that the graph, it goes all the way up, right? It doesn't stop. Okay, so this point here, it's not like a maximum or anything, because again, the arrow means that the graph actually continues, right? So it doesn't stop, it goes all the way up, all right, to infinity. Okay, so here there's no maximum here, okay? Because if you take like this point and you say this is like a local maximum, but I would say, well, the next one. Oops. I'm gonna mute you guys because, okay. So then the next one here would be higher, right? Higher than the blue point would be higher than the green one, right? So then, so there's no maximum here, because as I said, so if the line goes all the way up or all the way down, like here on the other side, okay? So here, because this line is supposed to go all the way down, so there's no minimum here. Okay, so because if you say, well, this blue point it's a minimum, well, I would say the next one, like this green one here, would be lower than the blue one, right? So, and because the line doesn't stop, it goes all the way down, so there will be no minimum there. Okay, does this make sense to you guys? So if you see like an arrow, if your graph like goes all the way up or all the way down, then there'll be no maximum or minimum. Okay. All right. Now, so now let's go to the next point, which is here at -2. So you can see here at -2, if you take this point, the blue point here, right? And you take a neighborhood of that point. Let's say you take this yellow neighborhood, a small neighborhood around the blue point, then the blue point would be like the lowest point in this yellow neighborhood, right? Because if you take any other point in this yellow neighborhood, the blue one would be the lowest one, right? So that would be a local or a relative minimum, right? Because the blue point would be like the lowest point in this small yellow neighborhood. Okay, so then so x equal to -2 would be a local or relative minimum. Okay, does this make sense to you guys? Any question about why this x equal to -2 is a local or relative minimum?
Professor, I have a question.
Yes.
Yeah.
So
So
I
there
think
is,
Rabiul, sorry, Rabiul, I forgot you had the question before in the chat, and I forgot to answer actually.
oh yeah, this is the same question. Like,
Oh, okay.
If,
Okay, perfect.
yeah. So here we have two like minimum slope. One is -1 and one is 1, right? There is like two curves.
Negative. You're saying we're gonna have like two local minimums, right? -2 and +1.
Yeah.
Yes.
So
That's right.
like what is the question format? Like like how you asking us to find out the which one? Do you ask like find the local relative local minimum? Or
Yes. Like it's like in the homework number 2. I mean, if you take a look to the homework number 2, I think
yeah.
in the first problem, number 4 and 5, it says you have to find the values of x at which f of x has a relative maximum, or f of x has a relative minimum. So it's exactly the question I asked here. It's the same question. Find find the values of x at which f of x has a local minimum or local maximum.
So the lowest point is the local minimum.
Excuse me.
The lowest point is the local minimum.
The lowest point. Yeah, I mean the point is so this is a local minimum, right? But you actually you just have to specify the x. The x is -2, right? So all you have to, and your answer, you have to say, well, at x equal to -2, we have a local minimum or relative minimum.
Okay, so I have another question about range. So this is a infinity range, like minus negative infinity and positive infinity, right?
Yes.
The range is because the curve, the line is not finished either side.
Yes, either side. Yeah. So the line or the graph, it's continuous. It doesn't stop it doesn't stop here. Like it doesn't stop here. It goes all the way up to infinity. It doesn't stop.
Yeah.
So
like,
there will be, yes.
Like our homework is like it goes down, but it's not stopped. So it's like infinity continuous line.
Oh yeah. It's the same thing. Yeah, absolutely. Yeah.
Okay, thank you, Professor.
That means that if the curve at 1 would be like lower, a little bit lower than 2, then it would be 1 instead of -2.
Yes.
All right.
Yeah.
Professor, on the homework, they were both going downward. So it would be negative infinity to negative infinity.
What would be negative infinity? You mean the
Like, all right,
the minimum? The minimum?
No, I'm talking about the
range?
Yeah. Because they're both going downwards instead of going up. Like this one has one going up and one going down, but they're in the homework, they're both going downwards.
Yes.
They're both on the negatives, right?
Yeah. But but the range, it's another story, right? To find the range, so we said
intercept.
yeah. Yeah, it's we have to use like horizontal lines. You go from the bottom to the top, and whenever your horizontal line intersect the graph, then that will be a point of the range. So like in the homework, so we have this graph with the two arrows going down. So you start from the bottom. You are looking for the range, right? You start from the bottom. So your horizontal line at the bottom, of course, is going to intersect the graph, right? Because the both lines they go down, right? So your range it starts at negative infinity. Okay.
Okay.
You know, for the range, you have to find the interval. It's like you know, like here in this like in this graph, I would start like from the bottom here. Okay, we do have intersection. Well, then I'm gonna start at negative infinity, and then still having intersection, right? And I can go all the way up, you know, and still have intersection. So like here, the range would be like negative infinity to positive infinity, right? Because all my horizontal lines, they would intersect my graph. But it's different in the homework. And the homework, like, is gonna, the intersection is gonna stop at some point, I guess, right? You see
Yeah.
what I'm saying?
For the homework,
Yeah, yeah, in the
No,
homework,
it doesn't
I
stop.
I
The
think
arrows
it
are down.
doesn't stop. That's
No.
that.
He's saying in the positive it does, because like it goes downwards. So like the peak on top, it only reaches to like I think 4,
yes,
and then it goes
yeah,
back
4.
down.
Yeah, yeah.
We have only
Absolutely.
That would
peak,
be an
but it
interval,
doesn't
but
stop either way for the homework.
Yeah,
that
but no,
graph is
it's
confusing.
really positive though.
Can you go over through it, Professor?
Please.
so okay, so well, I'm not supposed to solve the, you know, the problem, but I'm
No,
okay,
don't solve
I'm
it.
gonna,
Do something similar, Professor.
I'm gonna do something similar.
Yeah,
All right.
do something
Okay.
similar. Yeah. Thank you, Professor.
Okay, so this is about the
Yes.
homework. All right, so let's say we have something like okay, like this here. Okay, like this, and let's say this point here is I don't know, let's say 5, for example, right? And you want to find the range, right, of this graph. So of course, here in the bottom we have negative infinity, and here in the top we have positive infinity. Anyway, so you start with the horizontal lines from the bottom here, and we do have intersection because our the graph, it goes all the way down anyway. So it's gonna intersect here, and it's gonna intersect here, right? So my range is gonna start at negative infinity. And then I'm gonna go all the way up, you know, with my horizontal lines, they still intersect the graph. I'm still intersecting the graph. I'm still intersecting the graph, right? So my range is gonna go all the way up to, and then where will be the last point where I'm gonna have intersection?
5.
It's
5.
5. So I'm gonna stop here, and that will be my range. So it's gonna go from negative infinity to positive 5, because after positive 5, there will be no intersection. So then the answer here, like the range would be like negative infinity, positive 5 included, because, you know, there is an intersection at there, right? So that would be my range.
Okay, thank you.
Okay.
But
Thank
how
you,
would
Professor.
how would we write it for the minimum? Like, do we write no
No,
minimum?
no. So that's not, sorry. No, I'm talking about the range here.
No. Yeah, I know. You said that you
Okay.
were done with that though.
Okay. Okay.
I'm
Well,
s-
first, does this answer your question about the range?
Yes,
Anyone
thank you so much,
else?
Professor.
Okay, perfect then. So now let me come back to the oops. Let me come back to the local maximum and local minimum, right? Okay. All right. So yeah. So here we do have like a yellow line. I don't know why. Okay, I cannot erase the yellow line for some reason. But anyway, so okay. Sorry about this, guys. Okay, so here it's x. We said x equal to -2. That's a local minimum. Now, next point. Well, as you can see, like here, this point here. Oops. So this point here, this one, if you take a small neighborhood of that point, you know, like this yellow neighborhood of the blue point, right? Then the blue point would be like the highest point in this in this yellow neighborhood, right? So what I'm saying is, if you take any other point in this yellow neighborhood, the blue point would be higher, the highest one, right? So then this point would be a local maximum, right? It's not actually a global maximum because obviously it's not the highest point in the graph because you know, like we have this line which goes all the way up, right? So it's not a global maximum, but it's a local maximum actually, right? And so the corresponding x, as you can see here, the corresponding x is 0. So here at x equal to 0, we're gonna have a local or a relative maximum. Okay.
Alrighty.
Yes, please.
For example, the minimum is -3, and the maximum is 0, right? On the top.
Minimum is you're saying minimum is -3?
-2.
Oh yeah, we said yeah, negative. Yes, we said at -2.
Maximum is 0.
Well, we'll still have another local minimum and local maximum actually, because now if you take this point, you see this point here, and you take like a neighborhood of that point, then the blue point would be the lowest point in that yellow neighborhood. So this is also a local minimum. So
Yeah,
at
Professor.
yes,
Sorry for interrupt you.
yeah.
Like, yeah, if I ask more precisely, how we determine our neighborhood?
Just take a neighborhood, take a neighborhood of the point, the point itself.
Like,
So if you decide if
is it given? Is it given the neighborhood?
no, it's not. No, it's not given. No, it's not given. But the idea is you have to look for something which has the shape of like a parabola. So if you have like a small parabola somewhere, like a mountain, like a small mountain or a hill, okay, then the point, this one here, that will be a local maximum.
I would think of it as something holding a ball. Like if you put a ball on a line, right? Then that's where it's gonna go.
Yeah, like
Right.
the top of like a top of a small mountain, or you know, yeah, or a ball, yeah.
Right.
Or the other way, if you have like, if you reverse like
Exactly.
this, okay, then the bottom, this point here in the bottom, you see this point, that will be a local minimum. So that's the idea.
Right.
Okay, so
I'm dead.
yeah, or a roller coaster. Yeah.
Exactly.
I mean, yeah, exactly. So yeah, so like at +1, you see guys, at +1 you have like sort of like a here, you know, it has the same shape like this one here, right? So then this x at +1 would be a local minimum. Okay. So any guess what will be the next? Is there any other local minimum or local maximum?
2 is local maximum.
Yes, very good. So you see at 2, guys, absolutely. So you see at 2, you have this like a small mountain here.
Yes.
So the top of the mountain, that will be your local maximum.
Exactly.
Okay, so like this one here, that will be your local maximum. So yes, absolutely, very good. So that's x equal to 2. That's also local or relative maximum.
So it could be more than one.
Oh yeah, of course. Like here we have like 2 local maximum and 2 local minimum.
So in case that there's something asking for this, like this one, then you will have to find both of them, right? Like.
Oh yeah, you have to find all of them. Yeah, sure.
All right.
Yeah. Okay. Yeah. You have to find all of them. Absolutely. Okay, so, well, I'm gonna give you an exercise, guys, so you can practice. You can see if you understand this notion of local max and local min. So here's an exercise.
Professor, the -2 and 0 is the global, right?
Excuse me?
The -2 and the 0 is the global, right? The global maximum.
No, they're not. They are not, because like at 0, so you're saying like so you're saying like this 0 here, this point here would be a global maximum?
Yeah.
No,
Is it
but
the highest?
no, it's not, because you see, if I compare it with this point here, you see this one here, the yellow one here, well, this one would be higher.
I guess there is not global maximum here. If it's
Yeah, there's no,
The
yeah,
arrows.
absolutely, very good. Yeah, because of the arrows. Yes, because of the arrows, because we have an arrow which goes all the way up, it doesn't stop, so there'll be no global maximum. And the same thing for the other arrow here going down, so there'll be no global minimum. Yeah.
Okay.
So yes. So yeah, so let me just write down here for you guys. So there's no a global max or global min. All right. Okay, so here's an exercise. I don't know how to erase this yellow line. That's that's annoying.
it's crazy.
It's crazy.
I thought you put it there on purpose.
No, I didn't put it there. I don't know how to erase. That's annoying. All right.
Long press on it, Professor.
No.
Long press.
No, it doesn't do anything. Nope.
Actually, there's yellow spots coming on the screen now.
I'm sorry, guys. I'm gonna stop sharing, and then I'm gonna share again the board, because it's annoying, I guess. I don't know how to get rid of this yellow line. I'm sorry about this. I'm gonna stop sharing and share again. Okay, now we're good. I'm sorry about this. All right. And am I recording? Okay, yes. All right, so here's an exercise for you guys. Exercise. So this is similar to the problem in the homework, homework number 2. Okay, so all right, so we need to find the values of x at which f of x has a relative maximum or relative minimum. Okay. So here's my graph. So this is +1, 5. All right. So let's say we have the following graph. Okay, so this is my f of x. All right. Hey guys, let's say you have 2-3 minutes to think about this exercise. All right. I'm sorry. I mean, my graph is not perfect, but
So we got 2 and 2 again.
Yep. 2, 2, yeah.
Local minimum
Negative 4.
-4 and -1, and the
Yep.
-2 and 2 positive.
Yes, and positive too. Yes, absolutely. Yeah, very good, Beth. Yes.
Thank you.
Yeah. So, well, that's good. That's very good. Yeah, right behind it. Yes, Eliani. Yeah, absolutely. The range, Abul, nope, it's not negative infinity 4. The range here would be negative infinity, positive infinity.
Right.
Okay, because you have this arrow, this one here, it goes all the way up. So you're gonna have intersection, from negative infinity to positive infinity. So yeah, I guess probably you're done, guys. I mean, if you understood how it works, then it should be. It's not. I guess it's not. Yeah, it's easy now. So I guess so. The first local minimum would be here, right at this point, and we're gonna have another. Yes, Eliani. Yeah, please.
Because Babu said that he mentioned the range, and you said that the range is negative infinity to positive. So on the right side, that arrow is positive.
The right arrow? No,
Negative,
no,
'cause you
no,
read it.
it's not.
You
It's
read it from
negative.
the bottom.
You go from the bottom. So you
Mm.
see, I go here from you start from the bottom here, and at the bottom I do have intersection. So it start from the bottom. That's negative infinity at the bottom, right? And then we go with your horizontal lines up all the way to the positive infinity, and you still have intersection, right?
Yeah. Okay. Thank you.
Mhm. So yes, very good there, Abdul. So we do have a local minimum at, as you said, guys, at -4 and at -1 here. All right, and we're gonna have a local maximum here at -2 and at +2. All right, so the answer, so a local min at x -4 and x -1, and we do have local max at x -2 and x +2. Right? Does anyone have trouble to find the local min and local maximum here? Okay, perfect. That sounds good. All right, guys. So then, perfect. So then we are done with the local maximum, local minimum, and so let's finish this section 1.3 with the last thing. So
Wait.
Yes.
The one in the homework was a parabola where like they're both facing down.
Yeah.
So
what's the problem with that?
Right, because there's still stuff to like a point to write down in these. What do you do if if there's no point?
Oh, if there's no point, there's no. There's no local maximum or local minimum.
So you just write no.
Yeah. Yeah.
All right.
Yeah, so the last thing, guys, to finish this section 1.3, it's, we use equations to describe functions, but actually some functions can be described with more than one equation. Okay, so, oops. Okay, so next. So sometimes functions can be described with more than one equation. Okay. So that's why what we call actually piecewise functions. So definition. So a function defined by two or more equations, equations is called a piecewise function. It's called a piecewise function. So let me give you an example. So what do I mean by a function described by two or more equations? So here's an example. So how do we define such functions? All right, so here's an example. So here's my f of x, and I'm gonna say that my f of x is equal, and then we're gonna have, like, let's say let's say this function f is defined by three equations. Okay, so I'm gonna have like three equations, like let's say x squared minus 1 and 2x, let's say plus 2, and let's say x cubed minus x. All right, and so we have three equations, right? But of course, remember, guys, the definition of a function, for each input x, there's exactly one output, right? Y. So we cannot really have three equations at the same time. We cannot have like three different answers at the same time, because otherwise f is not a function, right? So in order to be a function, we always have only one answer or one output. So the thing is, so we're gonna use, let's say, the first equation, x squared minus 1, if, so there is a condition here to use the first equation. So the condition to use the first equation is, so if, let's say, x is, let's say, less than 0. Okay, and I'm gonna use the second equation if x is between, can be larger or equal to 0 and less than 3, for example. And I'm gonna use the third equation if my input x is larger or equal to 3. Okay, or let me write it the other way here. So x is larger or equal to 3. Okay, so for example, let's say you want to find f of -1, right? So here, f of -1, I want to compute f of -1, but there are like three different equations, right? As I said, there's this equation here, this one here, and this one here, right? So I need to decide which equation I'm going to use. And again, guys, we are not allowed to use all of them at the same time, because we have a function, so we have only one output. Okay, there will be no, like, you cannot have more than one output. Okay, so I have to decide which equation to use, right? So we have to decide which equation we're gonna use. Okay, now how do we decide which equation we're gonna use? Well, the thing is, we have to check your input. So my input x, so here I'm saying my input x is -1, right? And now I'm gonna check these conditions here. I have like three conditions, right? And if one of the conditions is satisfied, then I can use the corresponding equation, right? So for example, the first condition here, so I'm allowed to use the first equation if my x is less than 0. So my input x here, it's -1, right? And of course, -1 is less than 0, right? So this is less than 0. So if it's less than 0, so then the first condition is satisfied, and so I am allowed to use the first equation. Okay, so less than 0. So we have to use the first equation. Okay, and actually you cannot use the second equation because the condition for the second equation is that your x is, as you can see here, your x is between 0 and 3. But my x, it's -1. It's not between 0 and 3, right? So the condition there is not satisfied. So this condition here is not satisfied. That's why I cannot use the second one. And the same for the third. The condition is my x is larger than 3. But my x here, it's -1. And -1, of course, it's not larger than 3. So that's why I'm not allowed to use the third equation. So the only equation I'm allowed to use is the first one, because my x is less than 0. So here, to answer this question, so we have to decide which equation to use. So so then it turns out that we have to use the first equation, right? So we use the first equation, right? So then f of -1 would be like, so here's it's x squared minus 1. So it's -1 squared minus 1, right? I just replace here this x here by -1. So of course, -1 squared, it's -1 times -1, that'll be +1. So that's like +1 minus 1. And so the answer is 0. Okay. So that's what I call a piecewise function, right? So it's defined by 2 or more equations. Like here, it's defined by 3 different equations. But for each input x, guys, you are allowed to use only one equation. You cannot use all of them or 2 of them because it's a function and you are allowed to only have one answer. You cannot have more than one answer. So like f of -1 here would be just 0 and nothing else. Okay, let's take another. Let's say you want to find f of +1. Okay, let's say you want to find f of +1. F of +1. So when you say f of +1, it means my x is +1. My input x is +1, and so I have to find. Yes, Rabiul, absolutely. So I have to decide which equation I'm going to use. My input x is +1. Obviously, it's not less than 0. I mean, +1, it's not less than 0. So I cannot really use the first equation. The second equation, well, my x is between, if your x is between 0 and 3, and yes, my x is between 0 and 3. +1 is between 0 and 3. So I have to use the second one. And of course, you cannot use the third one because in the third one, your input x should be larger than 3, and my input is 1, so it's not larger than 3, so I cannot use the third. So the equation I have to use is the second one. No. It could be actually it could be different options, and you could have like more equations. Like you can have like 4 or 5 or 6. Okay, it doesn't have to be 3 equations. You could have more equations. It depends on the problem.
But you see, like the if, like the
Yeah,
x
the
smaller
conditions,
than,
right? The conditions is gonna be
is
different.
that
I
always
think
is
that's
that
right.
always the same?
No. No.
Okay.
You're gonna have very different equations. No.
Oh, it depends on every problem.
Depends.
Okay.
No, it depends on the problem. It depends on the problem. Yes.
Okay.
So
But we'll always have it.
oh yeah, of course.
Okay.
Yes. So first you have to check. Yeah, absolutely, Rabiul. So you have to check the conditions. You have your x, and so you check the conditions. So as I said, for f of +1, we have to use the second because +1 is between 0 and 3, and so the second equation is 2x plus 2. So then f of +1 would be like 2 times 1 plus 2, and so the answer is 4. Now I'm gonna give you let's do another one, which is kind of tricky. What about f of +3? Okay, so my input x is +3, right? So let's see. First one, x must be less than 0, and obviously +3, it's not less than 0. Okay, so we cannot use the first. The second one, it's x between 0 and 3, but x, as you can see, guys, is actually, this is strictly less than 3. I mean, it cannot be equal to 3, right? So if you have like a line under the inequality, then yes, then x can be equal to 3. But here, there's no line under the inequality, right? So here, x is strictly less than 3. So I'm not allowed to use the second equation, right? Now, for the third, as you can see in the third, x is larger or equal. So it can be equal to 3 in the third condition. My x can be equal to 3. So that's good, which means that I am allowed to use the third equation, right? Because, so again, this means that can be equal. Can be equal. Okay. So if my input x can be equal to 3, well, that's perfect because my x is 3. So then f of 3 here would be, f of positive 3 would be, so that's x cubed. So that's 3 cubed minus x, so minus 3. So that's 27 minus 3, and what would be the answer would be 24. Okay. So again, guys, you need to keep in mind, you are only allowed to have one answer, okay? You cannot have more than one answer. You have to decide which equation you're gonna use, okay? You cannot use more than one equation, okay? Because it's a function, and for each input x, there's exactly one output y. So this is actually similar to the problem. So in homework number 3, the first the first problem in homework number 3 is exactly this. So you have functions, piecewise functions, and you have to find the outputs y. Anyway, so here's an exercise. Unless there's a question about this example. All right, so here's an exercise. So this exercise is similar to the problem 1 in homework number 3. So homework 3, problem number 1. Okay. All right, so let's say here's my f of x, and f of x is, so let's say it's at 1 minus 2x if x is less than -1, and then x minus 4 if x larger or equal to -1 and less than 0, and then x squared minus 1 if x larger or equal to 0, less or equal to 2, and finally equal to 2 if x strictly larger than 2. All right. So we see here in this exercise we have like four different equations, and of course we're gonna have like 4 different conditions. Anyway, so please guys try to find so first f of -2, then f of, so find f of -1, f of 0, f of 1, f of 2, and f of 3. Okay, so let's say you have 5 minutes, guys, to think about this. Yes, Rabiul, absolutely, yeah. Yes, yes, very good review, yeah.
On the bottom, what do you mean by just 2?
Well, the output is always 2. Doesn't matter what's your X, the output is always 2.
Okay.
Mm-hmm. Yes, Lisbeth, you're correct. Review third, meet the third condition. Yes, yes, absolutely right. So Xing, you're saying yes. I think you're correct. Yeah, Xing. Yeah. Mm-hmm. Yeah, Rabiu, you're right. Yes. Wait. Number 5. Oh, yes. Yes, Rabiu. Sean, let me see. So, yeah, very good, guys. Very good. Yeah, I think last one is 2. Yeah, absolutely, you're right.
Professor,
Yes.
for the fourth condition, what is the X?
The fourth condition?
Yeah.
Well, X is strictly larger than 2. That's the
You see,
condition.
but there is no X like.
Oh, here.
Yeah.
Oh, you mean the output here?
Yeah.
Yeah, so here what we are saying is that the output is always 2. It doesn't matter what's your X, the answer is always 2. So this is like what we call like a constant function. So the the output is always the same. Doesn't matter what's your input, the output is always the same. So if you have a graph, right? So let's say this is 2 here. So what we are saying is that like if your X is -1 or +1, it doesn't matter your X, the output is always 2. So you're gonna have like just you're gonna have like a horizontal line. Okay, so like this is -1, this is +1, this is 5. So what we are saying is like f of -1, it's 2, f of +1 is 2, f of 5 is 2. So it doesn't matter what's your input X, the answer is always 2, right? The output, the level here would be always 2. So that's what I mean by this. So that's why we call what we call a constant function. So the output is always the same. It doesn't matter what's your X. I think there's another question in the chat. Yes, a constant. Yes, Eliani. Mhm. All right, guys.
Will you go over them?
Oh yeah. Of course. Yeah. Sean, f of e. Yes, Sean. Yes, f of e is 2. Yes. Yeah.
I wasn't sure. I thought I had to multiply it, but maybe not. Yeah,
Yeah. So, okay. So, yeah, let me go over them. So the first one, your input x is negative. Oops, come on. So, yeah. So your input x is -2, which is -2. Of course, it's less than -1. So it satisfies the first condition. So we have to use the first equation, right? So then f of -2 would be like 1. There's a minus here. So here's my -2 times x. My x, it's -2. And as I said, guys, my advice for you, whenever you have a negative number, use parentheses. It's better. Okay, it looks better. Okay, now because of the, you have negative, so this negative here, oops, negative, that will be a plus, and so that's 1 plus 4, that'll be 5. So the answer here will be 5. Next, f of -1. So my input x is -1, and so let's see the first condition. So the first condition is x strictly less than -1, right? This is x strictly less than -1, but my x is actually equal to -1. So it's not strictly less than -1. So the first condition is not satisfied. Now, if you check the second condition here, you can see there's this line here, which means that your x can be equal to -1. Okay, so it can be equal to -1. That's actually good news because my x is exactly -1. So I'm allowed to use the second equation, which is x minus 4. So that's x minus, so that's x is a -1. So that's -1 minus 4, which is -5. F of 0, the same thing. So my x is 0. Here, in the second condition, x is strictly less than 0. So it cannot be equal to 0. But the third condition, x can be equal to 0, right? Because of this line. So if my x can be equal to 0 there, then I'm allowed to use this, the third equation, right? So so that will be x squared. So my x is 0. So that's 0 squared minus 1. So the answer is -1. Fourth, f of 1. Well, so my x is a +1. And as you can see here in the third condition, x is between 0 and 2. Well, my x is 1, which is between 0 and 2. So this condition here is satisfied. And so I'm allowed to use the third equation, right? So that's x squared. So that's 1 squared minus 1. And so the answer is 0. Now, f of 2. As you can see in the third condition here, x can be equal to 2, right? This x here, it can be equal to 2. So I'm allowed to use the third equation, right? So that's because my input x is exactly 2. So it can be equal to 2. So then I'm going to use the third equation, which is x squared. My x is 2. So that's 2 squared minus 1, which is 4 minus 1. And so the answer is +3. And finally, for the last one, my x is 3, which is obviously larger than 2. So this condition here is satisfied. So the answer, the output is this one here. There is no x there. It's just the number 2, and which means that it doesn't matter what's your x, the answer is always 2. So the answer here is always 2. So it's f of a is going to be 2. All right. Any question, guys, about this exercise? So again, the homework number 3, the first problem is exactly, I mean, is similar to this one, to this exercise. All right. So if there's no if there's no question, guys, then we can, I guess, we are done with this section 1.3, and we can move to the next next section. All right. So I'm gonna go to the section. I see. Yeah, let's go to the section 1.7 first. So in this new section, so we're gonna study. So yeah, we're gonna play with the functions. So it's about combination and composition of functions. Okay, so what we're gonna do today is, we're gonna do algebraic operations on functions. Like, for numbers, you can add, subtract, multiply, divide numbers. And actually, we can do the same for functions. We can also add, subtract, etc. Functions. Okay, so what we're gonna do today is we're gonna do algebraic operations on functions. So what do I mean by algebraic operations? It's just addition, subtraction, etc. Operations on functions, like addition, subtraction, etc. Multiplication, division, etc. All right. Okay. Well, so I'm going to introduce some notation here for for these operations. So notation here. Right. So let's say you have two functions, f of x and g of x. Okay. Let's say, so let f of x and g of x be two functions. So we have two functions, f and g, two functions. Okay. And so I'm gonna denote the sum of f and g. So I'm gonna denote. So we denote. So we write. So f plus g. So the sum of the two functions, f plus g of x. So this is just the sum of the two functions. So that's just f of x plus g of x. Okay. So this is just notation for a sum of two functions. Like, so I have these two functions, f and g. So denote the sum by like usual, usual notation of sum. So it's just f plus g, right? So for example, let's do an example here. Example. So let's say f of x, it's minus 2x squared plus 5x minus 3. All right, that's my first function. My second function, g of x, it's, let's say, 5x squared minus 3x plus 2. Okay, and let's say what we have to do here is to compute and simplify f plus g of x. So again, what do I mean by this f plus g of x? It means the sum of f with the function f with the sum with the function g, right? So so this is just the sum. So you can guess this is the sum of f with g. Okay, so how do you compute that? I mean, you can just, it's a natural way to add functions. So it's just like, as I said, it's just f of x, sorry, plus g of x. So that'll be equal to, so what's my f of x? Well, my f of x is this expression here. It's minus 2x squared, minus 2x squared plus 5x minus 3, right? That's my f. So this is my f, right? And then you have plus, and then there's g. Okay, so where's my g? Well, here's my g. G is just g of x is just like 5x squared, you know, minus 3x plus 2. Okay. And then, guys, the important thing here, you don't forget to simplify. So here there are some simplifications. Yes, Logan, yeah, I think you got that right. Yes, very good. Absolutely. That's the right answer. So guys, here you have to simplify. Okay, it's really important to simplify. So you have to simplify your answer because as you can see, like, you know, you have like this minus 2x squared here plus 5x squared. So then you end up with plus 3x squared, right? And then we have like plus 5x minus 3x, right? That will be plus 2. Yes, Rabiul, absolutely. Plus 2x. And then minus 3 plus 2, that's minus 1. All right, so the answer here, the answer would be, so f plus g, the sum of the two functions. So as you can see, guys, this is just like natural addition, right? It's nothing fancy here. So this is just 3x squared. But don't forget to simplify your answer, right? So, okay, so that's for the addition. Now I mean, you can guess. It's the same thing for you know, for subtraction, you know, division and multiplication, right? So we're gonna do the same thing. Okay, so so as you can guess, so notation here. So so this is the sum, f plus g of x. As we said, it's just f of x plus g of x. So we can guess same for subtraction. So we're gonna have f of x minus g of x. The sum, multiplication, right? With a dot. So f dot g. That's the multiplication. So that's just f of x times g of x. All right, with a dot. And finally, the division, f over g. That's like f of x over g of x, right? Let me give you one more example, guys, just to, because you have to be careful, like with the subtraction, for example, because, well, we'll see. So, for example, let's say you have f of x 2x cubed minus x squared plus 1, let's say, and g of x, it's like minus x cubed plus 4x squared minus x. Okay, that's my f and that's my g. And now let's say you want to find and simplify f minus g. Okay. So then, right, so this is just so f minus g is just a natural thing to do, subtraction. So it's like f of x minus g of x. So anyway, so what's f of x? Well, so here's my f, you know, here's my f. So that's the 2x cubed minus x squared plus 1. And then there's this minus, and then guys, the thing here is we need to use parentheses for g. Okay, so I'm gonna use parentheses. Okay, and then inside the parentheses, I'm gonna put the g of x. Okay, so my g of x, of course, is you know, this thing here, minus x cubed. So it's minus x cubed plus 4x squared minus x. Okay, so the parentheses here are really important because, again, when you distribute the sign, it's gonna change some signs, right? Well, it's gonna change actually all the signs, like here. So So this would be equal like 2x cubed minus x squared plus 1. So this minus minus would be a plus, right? This, as you can see, guys, here minus minus, that's a plus now. That's plus x cubed. Yeah, Rabiul, I think you're correct. Yeah. And then there's a minus and a plus, so that will be a minus. Okay, so that's minus 4x squared. And finally, minus minus, so this minus here with this minus, that will be a plus. So last here, this thing here would be plus x, okay? And this, I mean, the signs here, they change, you know, completely the answer. If you get the wrong sign, of course, you're gonna end up with the wrong answer, okay? So it's really important, guys. Again, the parentheses are really important. Yes, Lorden, absolutely, it's minus 5x squared, yes. So, wait, yes. So, okay, we need to simplify the answer. So we got 2x cubed plus x cubed. So that'll be 3x cubed. Okay, we got minus x squared minus 4x squared. So as you said, guys, Rabiul and Lorden, that'll be minus 5x squared, right? And then, well, there's this plus x, and yeah, that's it. Okay, there's no x's there except this the plus x. So there's this plus x, and then there's this constant. There's only one constant, which is plus 1, right? So you're gonna have plus 1 here. Okay, so that'll be a final answer. So so your final answer should be, so f minus g of x, that will be this 3x cubed, you know, minus 5x squared plus x plus 1. Okay. So I did this subtraction here because I think that's where you have to be careful with the parentheses. But otherwise, yeah, also, I mean, obviously, like if you have a multiplication, right, a product, then you also need to use the parentheses, right? Because so you have to multiply everything, you know. Anyway, so here's an exercise, and there's a question about this example. So I'm gonna give you 2 functions, and you're gonna do a couple of operations on them. So exercise. All right, so let's say my function f of x. So f of x is just let's take something simple here. 2x, nothing fancy. 2x minus 1, and g of x. Let's say, let's see. All right, so let's say it's x squared minus 3x plus 1. All right. So please try to find and simplify f plus g, f minus g, and let's do the multiplication, f dot g of x. All right, guys. So let's say you have 5 minutes to think about this.
After, can you do an example of
Division?
multiplication? Yeah, with a fraction.
The fraction or multiplication. So this is going to be an example of multiplication, right? Well, we can do the fraction. I mean, sure.
Yeah, like because on the homework there's one that says simplify, and you have to multiply f and g, but the second one is a fraction.
Oh yeah, that's true. Absolutely. Yeah, let's do a f over g. Okay. Well, because I think in the homework it's more complicated than these functions here. But anyway, let's okay, let's do another one here. Okay, this is like let's say number 1, and this is the first exercise. Exercise number 2. So I'm gonna do something similar to the homework. So this is guys, this is similar to the problem number 2 and the homework number 3. So this is Homework 3, problem number 2. Okay, it's the same kind of question. Anyway, so exit number 2. Let's say I have f of x. This is probably 1 minus x and x 2x minus 4, and g of x equal to, let's say 1 over x. Okay, and then let's say you wanna find let's say find f over g. Okay, f over g of x. Sorry, this is a question in the chat, I guess. Oh no, you got the answers, Rabiu. Oh yeah, so yeah, for number 1, let me see. Yes, very good, Rabiu. Yeah, that's correct for number 1. There's something else. Let's see the chat. Yes, Rabiu, very good. Just probably just one suggestion. Like in your final answer, it's better to start with like the highest power of x. Like if your answer is like 5x minus x squared minus 2, it's better to start. I mean, your answer is correct, of course. But I'm just saying it's better to start with the highest power of x. So the answer will be like minus x squared plus 5x minus 2. Actually, guys, in the homework, yeah, so because in the homework number 3, so you have all these operations on f and g, but then you have to find like the domain. So after this, there's one more operation we're gonna see, and then we're gonna try to find like the domain of f plus g, f minus g, etc. Lord, and you're saying x squared minus x for first one. Yes, very good. Yeah, that's x squared minus x, absolutely. Are you done, guys? Let me see. Lorden, for number 2, you're saying minus x squared plus 5. Yes, that's correct. Rabiu. Oh yeah, the multiplication. I think I'm gonna do the multiplication because, well, I did an example of the addition subtraction, and so I need to do at least one example of the multiplication. Yes. So yes, I think your answer is Yeah, it seems correct to me. Yeah, it's correct. Yeah, very good. Yeah, very good, Rabiul.
Professor, for the second
Yes.
exercise, after we divide it, do we have to simplify the answer?
If it's possible to simplify, yes, please. If it's possible, I mean, it's not always possible to simplify, right? If there's a possible simplification, yes, please try to simplify. I mean, try to do your best. But sometimes there's no simplification, or Lorden and Rabiul have different answers. Lorden, you're saying -7x squared, but I think Rabiul answer is correct. I think should let me see. We have minus. No, I think Lorden actually is correct. It's -7x squared, Rabiul. I think you the -6x squared minus x squared, that'll be -7x squared, because you said -5x squared. But yeah, Lorden is correct actually. Eliani -2. Where? Oh yeah, for number 2. Okay, yeah, for number 2, yeah, there's -2 missing. Yeah, absolutely. Yeah. Yeah, Eliani. Yeah. Am I recording? Yes. Okay. Cool. All right, guys. You probably. Is there anyone? Does anyone need more time? Okay, probably not. I guess you are done.
Wait. Sorry.
Okay, no problem. Sure.
One more
Take your,
thing.
sure.
Sorry.
Okay, no problem. Sure. Rabiul, for number 2, you're saying it's x over 2x.
Sorry, try to read it carefully. I don't know. I try to. Okay, I'm done.
I think there's some. I think your answer is incorrect, Rabiul. I think there's something. Sean.
Okay.
Oh yeah, Sean. Actually, your answers are correct. Yeah, I think you're correct. You are done, I guess, right?
Yes.
Okay, perfect. Thank you. All right, guys. So for f plus g, I mean, I already did one example, right, with the f plus g. So I probably I won't do the details here, but for f plus g, so the answer should be, let's see. So it should be x squared minus x, right, and then -1 plus 1, that'll be 0. For f minus g, a subtraction, I already did an example, so I won't give the details for this one here. So, but the answer would be, we're gonna have minus x squared, okay, and then plus 5x, because it's 2x, and then we're gonna have minus 3x, so that'll be plus 3x. So it's plus 5x. And then we're gonna have -1 minus distributed minus, so there'll be -1. So that's -2. Okay. Now I'm gonna do Lorden, you're saying something? For number, yeah, I think you're correct. X minus x squared, and for division, yes. Yeah, very good. So yeah, I think I'm gonna do the multiplication, right? Because I didn't do any example like the multiplication, right? So so for exercise number 1, so I'm gonna do the f times g. Okay, so this is f of x times g of x. So guys, for f of x, I'm gonna need parentheses times, and then the same for g of x. I'm gonna need parentheses. So f of x, it's 2x minus 1. Yeah, now Rabiulu, you're correct. Yes, yeah, that's very good. So for f of x is 2x minus 1. So here's my f of x times, and then g of x is x squared minus 3x plus 1. So that's x squared minus 3x plus 1. All right. So now, guys, when you multiply two functions, as I said, you use parentheses. So then you have to distribute. Okay. So which means, so this 2x here, you're going to multiply the 2x by the x squared, and then by this 3x, and then by this plus 1. All right. And do the same with the 1 here. So 1 here times the x squared times the 3x and times 1. Okay. So that's what I mean by so you have to distribute, right? So 2x times x squared, that will be a 2x cubed, right? And then there is this minus. Okay, so here's my minus. So 2x times 3x, that will be 6x squared. Okay, and then plus 1, so this is plus 1 times 2x, so that's plus 2x. Okay, and then now we have minus, this is minus. Okay, so it's minus 1 or negative 1. Okay, so it's minus 1 times x squared. So it's minus x squared. Minus 1 times minus the x, right? This is minus the x. Minus minus, that will be a plus, sorry. That will be a plus. So it's plus 3x. And finally, it's negative 1 times a plus 1. A negative 1 times plus 1, that's negative 1. All right, and now we have to simplify. All right, so how many x cubed we have? Well, there's just this 2x cubed here. Okay, so here we're gonna have 2x cubed. Now, how many x squares? X squares, let's see, there's this x square here and there's this x square here, right? So that's minus 7 x squared. And then the x's, so let's see how many x's we have here. So 3x plus 2x, so that's plus 5x. And finally, there's this constant just by itself. This is minus 1 here, and so it's just minus 1. All right, so this should be your final answer, if I'm not mistaken, of course. Right? Is there any question about this multiplication, guys? Okay, perfect. All right, so now for division, yeah, so just be careful with division, right? Because so for exercise number 2, so when you divide, you have like f over g of x. So this is like f of x over g of x. Okay, so what's f of x? F of x, well, it's we have different functions, right, for number 2. So f of x is 1 minus x over 2x minus 4. So 1 minus x. I'm gonna use the next line here. Okay, so I was saying f of x is 1 minus x over 2x minus 4. So it's 1 minus x over 2x minus 4. Right, so this is my f of x over, okay, so I have this big or long line over g of x. And what's g of x? G of x, it's actually just 1 over x. So divided by 1 over x. So here's my 1 over x. So this is my g of x. All right? Now, guys, I mean, when you divide functions, it's like when you divide numbers. So if you have like a fraction over divided by another fraction, then you have to flip the fraction in the bottom, right? So this one here, you have to flip this one here. Okay. So what I mean is, so we have this 1 minus x over 2x minus 4 multiplied by, and then I flip the 1 over x, so that would be x over 1. Okay. So it's exactly the same, like this is exactly the same thing what we do for, for fractions with the numbers, right? When you divide two fractions, you have to flip the one in the bottom. Anyway, so now we have multiplication, right? So when you multiply, so you have to multiply the top, the numerators. So this 1 minus x times this x. So this is like 1 minus x times x. Okay, as you can see, I use parentheses for 1 minus x. And then the bottom, it's the same thing. I'm going to use parentheses for 2x minus 4 times 1. Right, you just multiply straight across here, right? And now, so the top, we're going to have like 1 times x, 1 times x, and then x times x. So that's 1 times x is x minus, because we do have a minus here, x times x, it's x squared over, and then here it's just times 1, so it's going to be just the same thing, which is 2x minus 1. Okay. So this will be the answer.
Wait, we don't simplify that?
The x?
Yeah, don't we gotta factor it? Because it looks factorable. I
Oh
factored.
yeah, you can. You can factor. You can factor out x in the top, but I mean it doesn't go away, right? It doesn't simplify. But yes, you can factor out the x in the top. Absolutely.
And I also did the 2 with the 4, right?
What did you do in the bottom, the denominator?
Yeah, I GCF is 2. Right?
Yeah.
Yeah, I got 2 with x minus 2.
Yeah, common out 2, like 2, like
Back
2
out
is
the
common.
denominator. 2 and 4.
Yeah. Oh yeah. Oh, you mean the factor out? Oh, okay. Yes, absolutely.
Yeah, 2 is the
so
yeah.
yeah. Oh yeah, you can factor out the x in the top, and you can factor out the 2 in the bottom. Absolutely, you're right. Thank you. Yes, you can do this. Yes. Yeah, absolutely. You're right. But I'm just saying it doesn't because it doesn't it doesn't cancel out. I mean, it doesn't. Yeah. But anyway, yeah. Is there any other question, guys? Okay, perfect then. No, okay, perfect. Thank you, Lord. All right, so this is for addition, subtraction, etc. Now there is one more operation we're gonna do, and then we're gonna also use the graphs to compute, the sum, subtraction, etc. So let's do the next operation and next and last operation on functions, and then we're gonna discuss the graphs. So next and last operation on functions is the composition. We're going to compose composition. We're going to compose functions. All right. So so what do I mean by composition of functions? Well, so let me probably start with an example so you can see what I mean by composition of functions. So the question, of course, it's what's a composition of functions? composition of functions. Okay. So I'm going to do an example. I won't give you like a definition. I'm going to do an example so you can see it from the example. So here's an example. Okay. So I'm going to take a function f, right? So let's say x squared minus x plus 1, right? And then I'm going to take a g of x, okay? And let's say g of x is x minus 1, right? So what do I mean? So what I'm going to do now is I'm going to compose the function f with the function g. So so how does it work? Well, so f. So we denote. So there's a notation here. First, I need to introduce some notation here. So we denote the composition of functions by so f. So f composed with g of x. So you see here for this composition of functions, so we have this like a circle. So whenever you see a circle doesn't mean multiplication of functions. So a circle, it means composition of functions, right? So be careful, guys. So there's a difference between a dot and a circle. So if you have a dot between two functions, that's a multiplication. But if you have a circle between two functions, that's what I call a composition of functions. Now, what's this composition of functions? Well, this is equal to f of g of x. Okay. So how do we compute this f of g of x? You know, guys, I mean, f of x. What's f of x? F of x is x squared minus x plus 1, right? So what I'm gonna do now, I'm gonna replace or substitute x. So this x, oops, come on. This is f of x. So I'm gonna substitute x with g of x, okay? So whenever we have x, there's an x in here, there's an x in here. So I'm gonna substitute x with g of x, okay? So here, this would be equal. So this x now is gonna be g of x, right? And there's a square outside minus next x, that will be another g of x here. And then there's a plus 1. Okay. So again, what I'm saying, so the composition of f with g is, so what you do is you substitute x with the g of x. So now, again, you think of the circle like parentheses. Well, actually, I don't know the answer, Abu, but probably you're right. But you think of the circles as parentheses. So we have like parentheses g of x square minus, this is minus, and then I have another parentheses. That's again g of x, all right, and then plus 1. Okay. So now what's g of x? Well, g of x, here's g of x. G of x is x minus 1. So I'm gonna have parentheses, right? X minus 1. That's my g of x. Here's my g of x, right? There's a square minus, again, this g of x, which is x minus 1. All right, and then there's a plus 1. Okay, and now, of course, you have to compute this thing and simplify your answer. So this is like x minus 1 squared. This is like x minus 1 times x minus 1, right? Minus another x minus 1 here. and there is this +1 here. Okay, so now you distribute, you know, like x times x, x times 1, etc. So this is like x squared minus x, and then do the same for 1. And so it's going to be another minus x, minus 1 times minus 1, that would be +1, right? And then there's this minus here, minus x, and then of course, this minus, that would be a plus. So that's a +1 here. And then at the end, we have this +1. Okay, now let's see how many x squares. So we do have 1x squared. How many x's? Minus x, minus x, minus x. So that'll be minus 3x. And then what about the constant? So let's see, we have +1, we have +1, we have +1. So that will be +3. Okay, so the answer here, F composed with G. So F composed with G of x is x squared minus 3x plus 3. Okay, I think probably Rabiu got the right answer. Yes. So anyway, so the idea, guys, you see what I did. This composition of F with G. So I took my F of x. As you can see here, here's my F of x, right? This is my F of x. And what I did, I substitute x by G of x. Okay, there's an x in here. It became a G of x, and this one here, it became G of x, right? And don't forget, please use parentheses. Like, think of the circle like a parenthesis. Okay, and so you replace your x with G of x, and then of course, and then you have to simplify. You know, you have to compute the whole thing, simplify, etc., etc. Let me just say one more thing here. There is a difference between F composed with G and G composed with F. So just remark here, F composed with G, this is different. Well, in general, it's different. This is different from G with F. So there are two different things. So for example, let me take a very simple example so you can see. So let's say F of x is x minus 1, and G of x is, let's say, 2x minus 3. Okay. If you do, let's do first F composed with G. Okay, let's find F composed with G. Right? So as I said, this is F of G of x. So what you do, you take your F of x and you replace x with G. You replace this x here with the G. Now what's F? F is just x minus 1. Right? So I need to take this x here and I have to replace it by G. All right? By G. Minus 1. There's this minus 1, right? So that will be equal to, so now what's this G? Well, G is just this function here, which is 2x minus 3, right? And then this is 2x minus 3, and then of course there's minus 1. There's, you see this minus 1 here, so there's minus 1. So the answer here, so that will be equal to, of course, 2x minus 3 minus 1, that will be 2x minus 4. So F composed with G, it's actually 2x minus 4. Okay. Now, what about G composed with F? Okay, now let's find G composed with F. So this is G. So G comes first. All right, and then G comes first, and then inside the parentheses we have F. So this is G of F. Okay, so G comes first and then F. So G of F, let's see what's G of F. So how do we compute such thing? Well, let's write down first g of x, and what we do is we replace x by f of x. So what's my g of x? My g of x is 2x minus 3. So what I have to do is I have to replace this x by f of x. All right, so this is like, so here we're gonna have like 2 f of x minus 3. All right. Okay, so let's do this. So that will be equal to 2, and then we have f of x. So I'm gonna use like a circle, that's my parentheses, and inside the parentheses I'm gonna put f. All right, and what's f? F is just well, it's the x minus 1, right? That's my function f. So this f here, it's just x minus 1. So this is x minus 1, and then there's this minus 3. Okay, so minus 3. Okay, so the parentheses here are really important, guys, because then you have to distribute. As you can see, I have to multiply 2 by x and then 2 by 1, right? So that will be equal to like 2x, and then 2 times minus 1, that's minus 2, and then there's minus 3. So the answer is 2x minus 5. So g composed with f of x, of course. So g composed with f, it's actually 2x minus 5. So we get, so as you can see, this is different from f composed with g. So f composed with g was 2x minus 4. Now g composed with f was 2x minus 5. All right, so in general, if you compose f, so if you put f first and then g, that'll be different from if you put g first and then f. Okay, so the order here is really important in the composition of the functions.
Wait, what was that again? That kind of confused me over this. So
yeah, please.
Where did that 2 came from? Like so
what the how I got this answer, the 2x minus 5 probably.
No, like if you
we're still using the from the top. We're still using the.
Oh, you're still using these two functions here from the top. This one, here's my f, and here's my g, right? That's what I'm using. That's what I'm using here.
Okay, I see.
So like here's my g. That's my 2x minus 3, and the x minus 1. That's here. That's it's given, right?
Oh, I see now. Okay, I got it.
All right, guys. So is there any? Okay, well, probably we're gonna have an exercise. Well, let's take a break before the exercise. All right, let's take a break at 10 minutes, and then we're gonna discuss this composition of functions, and then we're gonna discuss graphs, and also domain of sum, subtraction, etc. Anyway, okay, so let's take a break. I think it's good time to stop here, and so I'll be back. Let's take a break, 10 minutes, and I'll be back at the 8
9
oh
8:10.
You see, every minute counts for me, you know. Okay, 8 9 09. Let's say 09. Okay, let's be generous, right? So 09. All right, guys. I'm gonna stop recording like this. Okay.